Okay, I think it's good. Let me get this on. All right, we left off yesterday. Basically right here. We didn't really get to do much math stuff yesterday, but we did have a few minutes for you to kind of read through this. I asked you to go home and think about it some more and kind of finish this first example out. So let's talk about it all together for a few minutes here. And by the way, you may find yourself thinking sometimes that, gee, it doesn't seem like there's enough room to do stuff on this sheet of paper he gave us. That's not unintentional. The way I prioritize things is I don't really want to have to print, 3 pages of stuff for 80 people every single day. So probably you want to have, notes or a 3-ring binder or something like that to kind of put alongside this so you got more room to work stuff out. Obviously, I'm going to, kind of go off book sometimes too and throw some other stuff in. So just kind of be aware of that. But anyway, this first example, suppose your job pays you $12 per hour. And we're going to think of that as, that's your take home, right? So we're not worrying about taxes or Social Security withholding or whatever else. Just you get $12 for every hour you work. So with that in mind, I'm going to actually move down a little bit so I've got some more room. Example 1. Paid $12 per hour worked. If we know how many hours that you worked, how would you figure out how much money you should expect on your next paycheck? Okay, multiply. Multiply number of hours by 12. Why, Micah, should we multiply the number of hours that you worked by 12?
What do you make after how many other hours you work?
Okay, so if you make $12 for 1 hour, right? Then how much do you make for 2 hours? 24, right? Which is 12 times 2, or it's 112 plus another 12, right? All multiplication is, especially when we're talking about like whole numbers, multiplication is just a shortcut for addition a bunch of times, right? So if I take the number of hours and multiply by 12, that's going to give me however many hours I work, say it's 5, it's going to give me 5 12s, which is what I should be getting paid, right? If you want to think about it another way, if you want to look at like the units, if I take hours and multiply by dollars per hour, what happens to the units? Cancel, right? You got hours divided by hours, those cancel, and what are you left with? Well, right? The money that you should be getting paid, right? Okay, so that's all we need to do. Multiply the number of hours by 12, and ta-da, that's what should be on your paycheck, right? Okay, can you write a formula that would do that for you? So can we take that idea, take number of hours, multiply by 12, get an answer, and turn it into a formula? Okay, y equals 12x. And just a reminder, when we write things next to each other like that, we mean multiply, right? It's implied multiplication. Okay, y equals 12x, that works. Does it matter that we used x and y as the symbols there? No. What does matter? So the 12 is like kind of establishing the rule, right? Because that's how much we get paid. What matters about the symbols? Yeah. They're unknown until we actually like put something in, right? Get some more information. Yes, definitely. What else? Could I have written x equals 12x or y equals 12y? No, that doesn't make sense. They need to be different, right? That part's important. We're deciding what we want to use to represent them. If you want to call it, I don't know, hey, P equals 12H or something, like that's fine, right? That means the same thing. It expresses the same relationship, but it's important that those are different. The other thing that's important, and this is a thing that we'll talk about a lot when we do any kind of application or modeling thing, is knowing what they represent. If I just take this part and I'm trying to like explain how this thing works to somebody, and all I do is like take a scrap of paper and write y equals 12x and hand it to them, like what's y, what's x? Like I don't know what any of these things mean, right? Without some more context or something on it. So sometimes I'm gonna, make just a little note off to the side that's kind of like the like legend or the key about what these things are, right? So x, what is x here? Number of hours that you worked. If I say the number of hours worked, that gives me both some context and that it's, the time I did something, and also gives me the units, right? It's time, but it's time measured in hours. What's y? Money you earned. And I'm just going to make a note that's in dollars earned. Yeah, good. Okay, so now I kind of have a complete picture of like, yeah, the formula, but also what the formula is actually doing, right? What it represents. Okay, cool. How much would you get paid for working 25 hours? What do we need to do? 12 times 25, right? 25 hours, I'm giving you an X value, or T, or whatever you chose to label it, right? I'm giving you a value for this thing, and I'm asking you to figure out what happens for that specific one, right? So 12 times 25. Sorry, keep color coding a little bit. 12 times 25, and what's 12 times 25? 300, and those would be dollars, right? That's the number of dollars I should get on my next paycheck for working 25 hours. Okay, is everybody okay with all that? Like the mechanics, like what it all means, how we're doing that? Okay, great. This is, if you like think back to your previous classes, high school algebra, whatever, this is an example of a linear. That part's cool, it's a straight line, like whatever, it's got a slope, but more importantly, it's an example of a function, right? It happens to be a straight line, but it's a function. The thing about functions is what they do is take two things, in this case, the number of hours that you work and the money you earn on your paycheck, or X and Y, if you want to think about it as the symbols, and X and Y are kind of the things we use by like default most of the time, but it takes these two quantities and it pairs them together. It describes how they're related, how they affect each other. The way a function works is that one of the things is changing, and as the one thing, is it Kayla? Yes? Okay, you said something about like they're both unknown until we like know one of them, and then we can figure out the other one, right? Changing one causes the other to change, right? There are constant functions too, where maybe one changes and the other one doesn't. That's fine, but they go together, right? They depend on each other. The fancy word, if you want to impress your friends at parties, is co-varying, which sounds fun, but they change together. We can also go about this the other way. Most of the time, like this example, it kind of makes more sense to think about like, okay, I worked this many hours, this is how much I should get paid, right? And maybe your boss even asks you like how many hours you want this week, and you tell them, and then you kind of know like what you should expect to get paid from that. What if that same situation where like you get to decide how many hours you want to be scheduled for, but that your check next week, you need, I don't know, it's $240 or something, right? What does that change about what we just did? Right, now I know what I want the outcome to be, right? So this $240 isn't an X value in our formula, it's a Y, right? So if I make that substitution, then 240 equals 12, but the X part is still unknown, right? It's unknown, but it's unknown in a way that I can go and find it, right? So now here we substituted, right? I gave you a value, you plugged it in, you followed the instructions that were right there. As soon as I change that X out for 25, I've got the instructions right in front of me for what to do, right? This isn't a college algebra problem anymore. It's a third grade problem, right? Here, I want to find this, but I have to dig into it a little bit and decide what I'm going to do to get it, right? So what do we need to do to solve for x there? Let's divide by 12. I know what 12x's is. I want to know what 1x is. So divide by 12, and then x is 20, and I can tell my boss, okay, I want 20 hours this week, right? Good to go. But we're solving for an unknown thing. These two things, taking a given function and making a substitution, plugging in, and then figuring out what the answer is, or substituting in the other way where I got to kind of dig in a little bit and find the answer. This is solving an equation. Those two things are going to be almost all we do all semester long, just in different contexts and different settings. And, you know, obviously what we need to do here to actually solve the thing is going to get more complicated. But those two things are basically going to be what we do all semester long. Either you know an x and you go find the y that goes with it, or you know a y and you go find the x or x's that go with it. All right. So just kind of keep that in mind. I'll try to remind you about that a lot. But that's a good way to start a lot of, you know, fast forward to like number 7 on test 2 or something. A good way to start a lot of problems is going to be first thinking, do I know x and need y, or do I know y and need x? Okay. And that's going to, you know, kind of drive where you go from there. Okay, cool. Everybody good so far? Everybody still with me? Yeah, right on. Okay. Okay. Now this is an example of a function. And this idea of what a function is, what it does, how it works is going to be really important. This is, again, going to be a thing that we kind of come back to all semester long. So here's another little example. This same situation. If I work 8 hours this week, how much should I get paid? $12 times 8, 12 times 8 is 96. I should get paid $96. If I work 8 hours next week, how much should I get paid?
12 times 8.
Well, sorry, for let's say we're getting paid, you know, once a week, right? I work 8 hours this week, I get $96. I work 8 hours next week, I get 96 again, right? Okay. And if next week I work the same number of hours, but my check is, I don't know, $70. Well, okay, fine. Yes, taxes, withholding, whatever. Forget about all that. If my paycheck amount is different, then something has gone wrong, right? If I worked exactly the same number of hours but got paid a different amount, something is broken somewhere, right? Something didn't go the way it should. Now, if I get a raise or whatever, that changes things. But assuming not, then I should get the same amount for working the same number of hours, right? Okay. It's like, you know, me, our salary depends a little bit on like how many hours we actually have each semester. So my check for, you know, August, September, October, November, December, those should all be the same. If one of them's not, I'm calling HR, right? Okay. That's what it means to be a function. That if you do the same thing, you give the same input, you start with the same, you know, value like that 8 hours, you should get the same result back. Okay. If we want to think of that in terms of input and output, sometimes that helps. Let me scroll back to where I wrote this thing down. Here, it kind of makes more sense to think about the number of hours as being the thing that I have some like control over, right? Thinking of that as the thing that sort of goes into the process, into the machine. And then the amount I get paid as being kind of what comes back out, the output. But in order to be a function, one of these should always give me one of these. You guys find something?
103.
103 is going to be outside, just right around the corner here.
Thank you.
Yep. One of these should always give me just one of these, right? Okay. Now we're going to talk some like math terminology stuff. A relation is a set of ordered pairs. All this stuff that we've just done, we could express as an ordered pair. An ordered pair is just you pair two things that go together, like these two things that go together up, and you write them in a set of parentheses and you separate them with a comma. So if I wanted to write that as an ordered pair, I'd write 20, comma, 240. And in the context of what's going on here, I know that this is number of hours that I worked, and this is how much I got paid. And by pairing them together, we're just saying like, okay, these things go together, right? Okay. That's very general. A relation doesn't have any special rules. It's just these things go together. It's kind of like the way you use the word relationship in other contexts, right? Just to talk about, your life. So if I, ask about, or if you ask me like, who's in my immediate family, right? Somebody ask me, who's in my immediate family? Well, there's me, and there's my wife, Emily, and there's Riley, my son, and there's Ellie, my daughter. So the people in my immediate family are these three people, right? That is one input, right? One person that you asked this question toward, but I have three answers to give you, right? Okay, so that doesn't keep that like function relationship that we're talking about, right? The equivalent thing for the paycheck thing would be, I worked 8 hours this week and I got $96. I worked 8 hours next week and I got $50. I worked 8 hours the week after that, I got $2,000, right? Well, that's one question, right? The input, the 8 hours, and three answers. That is weird. I don't want it to work that way because that's inconsistent. I don't know how much, I don't know if I'm gonna get paid a lot or a little or what, right? That's like asking, who's in my immediate family? Well, I've got several answers to that, right? And they've all got several answers too, right? Everyone is kind of paired up in this like big web where stuff goes all over the place. What question could we ask here that's going to have just one answer that's going to be a function relationship? Well, you could maybe ask me like, who is your spouse, right? I only have one of those. That's a different thing. That preserves the function relationship. Because maybe not if we're like in Utah or something, but like that's a whole different thing. But you ask me like, who's your wife? I say Emily, and like that's it. There's just the one answer, right? You ask me who's my son? Well, I've got two kids who are of different genders, so there's one answer to that, right? Okay, that's the difference between a relation and a function. So a function is a special kind of relation because it's still stuff that's paired together. But there's this extra condition where, well, how can we describe the extra thing that a function does? The input thing, or the way that we wrote our formula before, the x, or the way that you sort of like direct the question, right? Like if you're talking to me about my relationships, I'm the input then, right? Because I'm the target, I'm the subject of it. Each one of those has just one output or y or answer that goes with it. So there's like uniqueness there. So a function is a special kind of relation where one input always pairs or matches or whatever one output. Oh, I didn't write a word in there. So thinking again about our like formula, right? Because of course a lot of the stuff that we're going to do is going to look more like that, right? Where we've got like a function that looks like a formula kind of. If you give me a number of hours worked, you give me an input like that, there's just going to be one answer back for it, right? I'm going to multiply by 12. There you go. That's how much you ought to get paid. Okay, let's well, no, let's keep going. A couple of other like math words that are going to be important and we're going to use a lot. Domain and range. These are descriptions of a function, right? So you have a function, the domain is all of the things that that function knows how to deal with as input, right? So if I ask the chalkboard, who's in your immediate family, like that doesn't make any sense, right? Because the chalkboard's not in the domain for that function. If you ask like, how many hours should I get paid for working, or sorry, how much money should I get paid for working desk hours last week? Like that doesn't make any sense. That's not a number, right? So that's not in the domain. The domain is the stuff that the function knows how to deal with. The range is the same, but for the output, right? The answers that you get back. So for our paycheck example thing, what does the domain look like there? What kinds of things are in it? Yeah, the X, and X is, what does X represent like for that problem in that context? The number of hours that you worked, right? So like say your job says, well, you don't have to work at all this week if you don't want to, or you can work as many hours as you want, but not more than 40, because if you work more than 40 hours, like the way things work change, right? So the domain then would be everything from 0 to 40, right? For that function. It doesn't make sense to talk about negative 10 hours because you can't work a negative number of hours. It doesn't make sense to talk about 100 because your job won't let you work that much, just 0 to 40, right? It's numbers in there, and those numbers represent how many hours you work. The range then would also be numbers, but those numbers are going to represent how much you get paid. And again, it's going to be kind of restricted, right? If you work no hours, you make no money. So it starts at 0. And then it will go up all the way to, well, whatever 40 times 12 is, or 80, I guess, right? Like it would be those numbers, right? Doesn't make sense to talk about stuff outside of that. Okay, so let's get another kind of example of what a function is, how they work. Take a couple of minutes and talk with just 2 or 3 people around you about this example number 2. You have a list of everyone in the room. So I give you a copy of the roll. Along with that, when I called your name, you told me how tall you are, right? So you've got those 2 pieces of information. How would you pair those together? Like that definitely makes a relation because it's 2 things that go together. How would you pair those together so that it's also a function, and what are the domain and range? So take a couple minutes and just talk about that.
Then I would come.
All right. So that's it's called being an adult. That's right. All right.
High five.
So when we and then the outside. It's fine to put an empty range so that we be. Yeah.
Okay, so we have these 2 lists of things, and we're going to pair them up, right? Name and height. We can either do it like this, right? Where I think of the name as being like the first thing, or the input, or the X, or the element of the domain. I can do it that way. Or I could, hang on. Or I could do it this way, right? Those are my 2 options, right? One is the domain, one is the range. I get to decide which is which. Does it matter? Which way should we do it? And again, does it matter? Okay, if it's just those 4 people, me and Jack and Kayla and Ariana, does it matter? No, why not? What would be a problem? What's a function supposed to do? Relate things in such a way that what happens? One thing pairs with one thing, right? One input pairs with one output. The question you ask has one answer, not multiple answers, right? That's why, me and my immediate family, that's not a function because you ask me and I have to answer with 3 things, right? That's a problem. Okay, so if I match them up this way, name with the height, right? If I ask, okay, raise your hand if your name is Kayla. How many people raise their hand? 1. Okay. If I ask, raise your hand if you are 5'9". Go ahead. Several people raise their hands, right? Okay, so one of those is a function, the other one's not. Which is which? The first one, right? Every person is unique, right? Even people with, 2 people with the same first name, like we'll just list the whole name, whatever, right? We're all, unique. We're all snowflakes, right? That is unique, but there are almost certainly more than one person with the same height, right? Let's pretend that Ariana is wearing tall shoes today and is 5'5". Now, if I switch things around and say, okay, who's 5'5", at least 2 people are going to raise their hands, right? Okay, that's a problem. That's the thing that we want to avoid. The way I would write that down, no, sorry. Wait, hang on. Did I say all that right? We'll be back up. If I ask who's 5'5", 2 people are going to raise their hands. That's a problem. Yes, okay. Which is why I can't do this the other way, because then I would say 5'5", and I would have to connect to several people. That's not a function. The thing that we have right now is a function, even though 2 people have the same height. We don't care about that. What we care about is one person having 2 heights, and that's weird. That doesn't make sense, right? That can't happen. So since it can't happen, if I set it up that way, then it's a function. Okay, so the way then to make this a function is to set it up so that the domain is what? It's the set of everyone's names, right? So the domain is just a list of everybody on the roster. I'm not going to write them all out. Oh, and I don't know if I've done curly braces yet, but curly braces we just use to say like this stuff goes together, right? So when you see stuff between curly braces, it just means it's all grouped together. It's a set. The range be a list of everyone's heights, right? If we want to make that pretty, maybe we put them in order, but really it doesn't matter. Being in a set, you're just in it or you're not in it. For the sake of doing it, just because I can't help myself, I'm going to write them in order. But and whatever other numbers we need in there to describe everybody in the room, right? And again, the other way around doesn't work, because the other way around, you're probably going to get multiple people answering to having the same height, right? Because that's not unique the way that names. Okay. Questions about that? Okay. One more thing to try to really drive this function idea home. I only know how to draw old school vending machines, so one with the big buttons that have a picture of the thing. How does this work? It's not a trick question or anything.
Press the button. Hit what you press.
Okay. Probably you got to put money in, but that's basically like turning the machine on, right? So don't worry about that part. You don't get to control the money part, right? If you want to get something, you got to put the money in. The thing that we kind of control, right? The input that we have, the choice that we get to make. Right. The choice that we get to make is that we push a button. And then what does the machine do? Right. It rattles around and makes some clunky noises and stuff. And let's say I push the Coke button here, and there's also Diet, and there's also Sprite. The thing that I get back from it is, I can't draw bottles either, but the thing I get back is a can of Coke. Is that a function? Yes, why? You push the Coke button, it gave you a Coke. What if you push the Coke button and you got a Coke, and then the person behind you pushed the Coke button and heaven forbid, they got a Diet Coke. This is serious stuff, folks. What's going on? Right? So the machine is not working, the function's broken. It's not functioning correctly. It's cool. I'm a dad. Like I get to do this. Before I had kids, it was kind of a gray area, but the machine's not functioning correctly if you push a button, and sometimes it does one thing and sometimes it does a different thing, right? It should be, you know, another way you can think of this function idea is it should be like predictable, consistent, like it does the same thing every time, right? So if sometimes you get one thing and other times you get a different thing, that's not keeping with the function idea, right? The machine's not working the way it should, and you know, mathematically what that means is that the function is not actually a function. It's still a relation because it's still, you know, you do one thing, it does a thing in response, but it's not a function. The domain here would be all of the inputs, all the buttons, right? I'm just gonna, yikes. Curly braces are hard, so like don't feel bad if your curly braces look kind of dumpy, because mine do too. It's all the buttons, right? I would list them out. And the range is all of the drinks. And again, you know, you just list them out. Okay. Now, in general, if a thing is a function, which of those two sets, the domain or range, is bigger? Or possibly bigger? Let me say it another way. Can this one be bigger than that one? No. Because in order to be a function, each thing there needs to go to just one thing here. So either they're the same size, this one that it'd probably be the same size, or maybe you got that thing where it's got two Coke buttons, right? Okay. So either they're the same size or that one's bigger than this one's. Right? Just like if I list everybody's names along with their height, there's 28 of us, or not everybody's here, but there's 28 of us or so. But if I'm going to list heights, I probably only need to write down about 12 things, right? Okay. All right. Now, of course, you know, hopefully this kind of helps reinforce like the function concept, the idea, what it is, how it works. Of course, most of the stuff that we're going to look at is going to look more, you know, mathy, right? We're going to have a lot of stuff that looks like a formula or a graph or something like that. One thing we need to figure out then is how to write that down. We do that with function notation. Notation always just means the way you write a thing is the way we write a function. So we can think of a function as a machine that takes X or takes an input and returns Y or output, right? So it's a thing that takes one thing and pairs it with the thing it goes with, right? And if it's a function, then it does that. So each of these goes with just one of these. The way that we write that is like this, or a way we can write it. Function notation looks like this. This says Y equals F of X. Okay, what are we using for Y, or what does Y stand in for? The output, the answer, the thing you get back. What's this guy? An equal sign. What does an equal sign mean? Yeah. Okay. What's another way, without using the word equals again, to define like what equals means? It's the same. It is, right? They're the same thing. They're identical. I can't tell them apart. Y is, Y equals, Y is the same as. F, well, okay, we're using F to just name the function. Function starts with F. We use F. We're not that creative when it comes to naming things. Sometimes we'll use, you know, G or H or whatever. It can be anything, except X or Y, because those are already spoken for, right? But if we got two, we might write one as F and the other one as G or something, right? But it's just the name. It's the name, so I don't have to keep writing down the whole formula or just like drawing the graph or something. I just needed a way to talk about it. So we name it F. These parentheses, well, the X is the input thing, right? It's also called the argument sometimes. It's the symbol that I'm going to use to write it down. Saying f, the way you read these parentheses is of, f of x, means I'm going to write down a function. I'm going to call it f, and the symbol I'm going to use for the input or for the argument is x. So when I write f of x equals 2x plus 3, like I did right here, what that means is I'm going to write down a set of instructions. And the thing I'm going to use for the unknown that I'm going to think of as the input, that's also called the independent variable, is an x. So if I take that x, if I give you a value for it so that it, is like a set thing instead of just being an unknown, then you can find the output, the answer, the y that goes with it. What does this one do? Like, what does that formula tell me to do? Take a thing, multiply it by 2, then add 3. Okay, so what this does is if I give you a specific x, right, a specific value, it turns it from this kind of high level like concept into a, third grade math problem, right? It gives you a specific set of instructions with like concrete steps to take to do it. So what this function does is takes a thing and multiplies it by 2 and it adds 3 to the result. So what does it mean then to find f of 7? Place x was 7. So anywhere there was an x, I'm going to write down a 7 instead. And this is what I mean about turning it from this kind of high level abstract thing, this function, into a very concrete arithmetic problem. Now it's just, well, do the stuff that's written out there, right? 2 times 7. And 14 and 3 is 17. So for that function, 7 comma 17, x then y, is an ordered pair where that function exists, where it lives. If we looked at a graph of it, it's a straight line, but one of the points it goes through is 7, 17. Right, that's what that means. That x goes with that y. And you can do that for any number that you want, right? Of course, 7 is just an example. There's nothing special about it. What about f of x plus 1? Can we use the same idea? Okay, let's try the same idea. Where there was an x before, I'm going to write an x plus 1. And does that then give me instructions for what I need to do next? Like, how can I simplify or clean that up? Distribute. We need to distribute. We need to be careful because I had one thing there before, just the x, and I replaced it with the sum of 2 things. So you're mixing multiplication and addition. You got to be careful about the order there. Distributive property comes into play. So we distribute that, which would be 2x plus 2. And then there's still the plus 3 that was sitting out there to begin with. And then we can take another step to clean things up further, right? Combine like terms, add the 2 and the 3, and we get 2x plus 5. Right now, all we're worried about is the mechanical part of that, like actually doing it. So is everybody okay with like how that worked? You replace one thing with the other thing, you do whatever it says to do. We'll talk more like next week about what that means, what that does to the function. But right now, just kind of the mechanics. What about the domain and range for this function? Shoot, sorry, I know I'm a bit overruled. Domain and range. Domain's all the stuff that it knows, all the x values that it knows how to deal with. Range is everything you can possibly get back as an answer. So let's maybe leave off there. Y'all think about that a little bit. We'll pick up there on Thursday. Read through the rest of this. And try. That doesn't mean you have to like know the answer or know how to do everything, but give it some thought and try to answer some of this stuff. That QR code on the front will pull up the graph I'm talking about in this last example. You are also should be in a pretty good spot to do most, if not all, of the stuff in section 1.2 in the homework. So, get in there and do what you can. If you have questions about things, of course, that's fine. I'll see you all on Thursday.